We are bridge number 4. So it's Kate, Nathan, and Ray. And we just want to tell you a little bit about how we designed our bridge, the materials we used, and just what happened during the testing and the failure. To begin, we started out with a design that consisted of a single layer bridge deck that had 2 girders running across the span of the bridge that were made up of composite beams, and also a simple truss coming up off of the deck. It was kind of like a box bridge concept. But then we changed our design concept after going into the frame shop and seeing the materials we had to work with and the prices. We decided the composite beam wouldn't work so well because they didn't have the sizes we needed or that we thought would be best to carry the load. And also we thought that system wouldn't have transferred the load as well to our trusses, and we really wanted to utilize our trusses and make them thick to carry a lot of compressive loads.
The materials we used, our members were all 1/2 inch thick, except for maybe a few on the top and bottom. And the glue we used was Gorilla Glue. And unlike super glue, it takes 2 hours to set instead of just a couple minutes or seconds. And we started out with like a regular hacksaw, cutting each piece, but we needed angles and it took forever, so we just used jigsaw and that worked fine. And we also used a drill for putting the holes in there. And Ray's going to tell you about construction.
All right, so like Ashley said, we were trying to transfer our load to our trusses, and that was like the biggest problem. So we had a deck like this, just 6 inches wide, and we put 2 3-inch pieces, left an inch gap. So this is like if you're looking, driving into the bridge. So that way we could have our trusses actually work. Like so once we put a load on here, that the load would actually get distributed out and then up the trusses. So we felt like we successfully accomplished that. So when we started construction, we built this deck first, and then we set the web members on top of that. As you can see here, we used weights and books to put extra pressure on the glue because the glue expanded, so we wanted to counteract that. We also felt like that gave us like stronger joints.
So we pretty much had a basic truss system and a deck that we wanted. So we had everything that we knew that we had right. So we tested it by pressing down on it to see what we needed to change or what we needed to add. And what happened when we tested it is that between the 2 on the bottom, it kind of bowed a little bit. And our trusses came together. And we found that we needed some improvement in like the very middle, along, I guess where the weight would be hanging exactly. So we got the rest of construction.
All right, so to counteract that, we put these on the bottom. So this would be like right here. And this that extra plate prevented it from bowing out like this, kind of made this deck rigid. We also put the holes on the outside to reduce weight. We didn't think having them that thick in the ends would be a big deal. We also put these gusset plates on the ends. We were afraid of joint failures, so we put those gusset plates there and take care of the joints a little bit better. Okay, we also, to meet the design requirements, we were initially thinking about putting a plate just on the ends, but after the testing, since we had the arms coming up, that gave us that spot. And then we also lost a little bit of our height due to construction imperfections. That's why we used the little thinner plate there. So we used this elevated deck to cover the rest of the height, and we put, you can see right here that are just these 2 little bars right here. And that also helped create instead of being a point in the center, it transferred the loads out to these points. So you had the weight coming down there. Is that it?
All right. The first testing that we did, obviously you guys were all here for that. The bridge really didn't deflect at all, which we kind of weren't surprised based on the thickness of the members. And it carried all the available weights that we had, so the decision was made to do further testing in the lab with the UTM. And when we weighed the bridge, it weighed 764 grams, which was kind of a lot. But this is the setup for the UTM testing. This was before the testing was started. When we tested the UTM, before it deflected half an inch, the bridge held 800 pounds, which gave a strength to weight ratio of 475 to 1. And after the deflection, we decided to continue loading it, and it held 1,000 pounds, which gave a strength to weight ratio of 592 to 1. That's the bridge after failure in the UTM. All right, so what happened first? It's actually kind of funny because the two things that we added that Ray told you about, the gusset plates and these slats on the bottom, were the two things that failed first. The first thing that happened was the gusset plate snapped horizontally, as you can see, and it happened on one side and then right on the other side. And that kind of was just an error on our part. We didn't really think about the fact that we put the grain parallel to the bridge deck, and we really should have done it perpendicular. That was just kind of a mistake on our part, but. The second thing that failed, like I said, the bridge deck cracked. You can kind of see it. It cracked all the way across here, right along this edge of this plate, which pretty much just shows that we should have extended this plate further. So that's something you could do in the future to make it stronger.
The failure type was serviceability. I mean, it did deflect first, but there was a lot of cracking that you could hear, and it didn't just all of a sudden fail at one time. The gusset plates went first, as Kate was saying, and then it just transferred through the deck. And so it was mostly a duct top failure. But also, this bridge was designed more for this project and the plate, especially where we put the two members going across the width of the bridge. So it may not have done as well, I don't know for sure, if it was a moving load, especially because our deck is very thin on top. And that was just used to meet the requirements to meet abutment A and the roadway was.
Do you have any questions?
Where'd y'all get the balsa wood at?
Friday, Frank, downtown.
We actually
We had asked the woman. They have like a big garage apparently that they store a bunch of stuff in, and they had like tons of balsa wood back there. We like went and asked her because we found a couple members and they didn't have enough that we needed. So we asked her and she was like, "Oh, we rented the garage," and she came back with like tons of stuff. So.
Yeah, they were actually like willing to make cuts for you too.
Yeah, they like cut a bunch of.
We were afraid of. We thought we were gonna have to cut one of these pieces.
The two on the bottom that we bought we bought two of these 6-inch ones, and they just cut that in half for us. So that was nice.
How many hours did you take to finish the project?
Well, we worked. Me and Ray and Nathan and Ashley all worked on it. Probably about like 8 or 10 hours one Friday.
Yeah,
and then most of it though was I think the glue.
Yeah, it was 2 hours that we waited. So we built this thing in stages. So every 2 hours we were putting weights on it, setting it, and you can only do it and like putting the gusset plates on. We had to like turn the whole bridge on this side and put weights down on it. So it was just built in 2 hour stages, and didn't want to leave it outside overnight. We didn't know if the moisture would affect the glue, so
And then
we just spent a couple days.
Yeah,
just
and then a
doing
few
it.
days after that, it was just kind of off and on working on it.
So originally you didn't plan on putting those bottom plates, that was kind of like an afterthought?
Yeah. Yeah, it's once we because we built it up like this before we put those like cross members on. When we put that load on it, we could see it bowing in.
Yeah.
And we noticed that there's going to be a failure down the center.
That's
We didn't do
definitely
something about it.
Yeah. Well,
Yeah,
originally,
sure.
like we were saying, we had originally planned on not having this exposed. We planned on putting another, but we kind of went over our height, and we didn't want to be that close on the height, so we had to add to get to the abutment A on the top instead. So that's why we ended up having to add.
Yeah, we weren't going to have that elevated deck right there.
Okay.
We were going to have another plate going across the bottom to block it in, but
Yeah.
Didn't work out that way.
So a quick note, this group happens to have the highest strength to weight ratio in the class.